In our previous problem, we faced a new challenge. We had 5 copies of one distinct item. So we had 5 $1 bills. And we needed to somehow figure out how to distribute those, or how to count how many ways there are to distribute those among 3 grandchildren. We had 2 assumptions, one of which I made a mistake when I wrote it down at first. A child can get anything between 0 $1. I think I had one $1 bill. So a child can get no money at all. Can get up to 5 $1 bills, or anything in between, right? So 0, 1, 2, 3, 4, or 5 of the $1 bills. And also the other assumption was that all of those $1 bills are distributed. We approached this by representing each of those 5 $1 bills that needed to be given out as a star, and then we separated how many stars a child got from another child by using a bar to separate them. And this is what's known as a stars and bars chart. So very simple chart. It can also be applied to zeros and ones. We could think about stars as being zeros and bars as being ones, or vice versa, but bars kind of look like ones. Now let's look at this in a slightly different context where it'll be helpful. And anytime problems start to get a bit more complicated, stars and bars are helpful to begin thinking about, because they can take a mess and make it into a much simpler problem. But it does sometimes require a little bit of thinking. So how many 7-digit phone numbers are there in which the digits are non-increasing? That is, every digit is less than or equal to the previous one. Let's make up a phone number. We'll say that we have this phone number 9. Well, then the next digit can be a 9 or anything below. So we'll say, let's say it has another 9. But then the next digit is a 5. Okay, well, the digit after that can be any number as big as 5 or below. So 5, 4, 3, 2, 1, or 0. So maybe the next digit is a 4, meaning the next digit can be a 4, 3, 2, 1, or 0. So maybe the next digit is a 2, and then the next digit can't be anything bigger than a 2, so maybe it's another 2, and then maybe a 0. So that would be a valid phone number, because you notice that the digits are non-increasing. Non-increasing does not mean they can't be the same, it just means they can't be increasing in sequence. The first way we might approach this is we might think, well, we have 7 slots, because, hey, you know what? We're counting the number of phone numbers, and we know the number of possibilities for the digits. So let's say that the first digit ends up being a 9, like in our sequence. So there are really 10 possibilities for the first digit. Now, if the first digit is a 9, there are still 10 possibilities for the second digit, because it could be a 9 all the way down to a 0. And the third digit could be any one of 10 possibilities, but if it's a 5, well, that messes everything up from here forward, or here backwards, if you will. In that, the next digit cannot be any one of 10 possible numbers, because this can't be a 6, a 7, an 8, or a 9. And so you might say, well, no problem. For this sequence, we would just say there are 6 possibilities for that fourth digit, and that would be correct if the first 3 numbers were 995, or perhaps even 985, or 975, or 965, or 955. But you can already see that keeping track of all of this is going to get very cumbersome. In fact, if the first digit were, say, a 3, well, then there would not even be 10 possibilities for the second digit, and already our plan is falling apart. So this is a very complicated seeming problem, because the number of possibilities for the next digit really are determined by what the previous digit was. I'm going to think about this in terms of stars and bars. And what I'm going to do is I'm going to say there are 7 stars because there are 7 digits. And the first star, or the first sequence of stars before I hit the bar, will represent the number of 9s that I have. So in this phone number here, I have 2 9s. So I'm going to place down 2 stars indicating that those first 2 digits are going to be 9s. And then what I'm going to do is I'm going to put down a bar. And that bar, what it's going to represent is it's going to say that we've ended with the 9s, and now we're moving on to 8s. Okay, so this means that we have times 2 9s. Or I don't have any 8s, right? So because I have no 8s, that means 8 is not going to get any stars. And I'm going to put down another bar, and there are no 8s. And in this way, we'll keep going. We'll say, well, now we're on to 7s. So the second bar terminates the 8s, and the third bar will terminate the 7s. So there'll be no 7s. No 6s. So the next bar will terminate the 6s. Next bar will terminate the 5s, but I do have a 5, and so I'm going to place 1 star there to indicate I have 1 5. I'm going to end the 5s. There's 1 5. And now we'll move on to 4s. Okay, so then, yes, I do have a 4, so I'll place 1 star times 1 4. I do not have any 3s, so I'll just place down a bar. No 3s. I have 2 2s. Times 2 2s. I have terminate the 2s. Now I don't have any 1s, so I'll just place down another bar. And now I have 1 0, so I'll place down another star. And that right there represents 9 9, no 8, no 7, no 6, 5, 4, no 3s, 2 2, no 1s, and a 0. And this is a perfect way of keeping track of this because we're letting each star represent a digit, and we're using the bars to distinguish between the values that those digits can take on. Let's take a look at another example. Let's say we have the number 6. Can't do anything bigger than a 6, so maybe we have 5, 2, and then maybe this one's a 1, and maybe the rest of them are zeros. So how would we set that up? Well, we first of all start off with 9s, and we have no 9s. So I'll place down a bar. I don't have, this would be the number of 8s going in here. I don't have any 8s. I don't have, this would be the number of 7s. I don't have any. The number of 6s, I have 1. Done with the 6s. How many 5s? I have 1 5. That ends the 5s. I don't have any 4s. I don't have any 3s. I don't have any 2s. I have 1 1. Terminate the 1. And now I have 1 2 3 zeros. Now pay attention, because all we need to know now is, well, how many stars and how many bars are we going to have? And we notice that we'll always have 1, 2, 3, 4, 5, 6, 7 stars. And 1, 2, 3, 4, 5, 6, 7, 8, 9 bars. 9 bars. Why would we have 9 bars if we have 10 digits? Well, just like in the case of 3 grandchildren, we only need to have 2 dividers, because if you take a line, for example, and you divide it and you place down 2 lines, well, that means you have 3 regions. You only need 2 lines to break up 3 regions. In the case of having 10 different possible digits, you need to separate them with 9 bars, and so that will ensure that they each have a slot. It's kind of like taking a line. If you take a line and you put down one bar, you have 2 regions. If you put down a line and you put down 2 bars, you have 3 regions. So it always is going to take the number of possibilities minus 1 bars to create enough separators to break up all of those regions. Okay, well, that is all that we need. in order to answer this question. So in total, we have 16 kind of slots, if you will. And now, if I think about stars and bars as taking up those 16 slots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, then what I need to answer is how many different ways are there for me to take 16 slots and either pick 7 of them into which to place all 7 of my stars, or alternatively, take the 16 slots and pick 9 of them into which to put my bars. So maybe my 7 stars, and just to keep this simple, will be here, 2, 3, 4, 5, 6, and 7. So there are 16 combinations, 7 ways to do that. And now notice that by default, I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9 remaining slots. And what needs to go into those 9 remaining slots? Well, it has to be the bars, right? That would be me placing the bars down. And there's only one way to do that because all of the remaining slots are just going to get bars. So we don't need to multiply this by 9 combination 9 because it's just going to come out to be 1. Combination 7, or you could also have 16 slots, and I'm going to pick 9 of them into which to place the bars, and then the remaining 7 will get stars. So if I did 16 combination 7, I get 11,440 different phone numbers. Where the digits are in non-increasing order. Notice how quick that was to solve. We just had to think about it a little bit, and we didn't have to take this ugly approach at all. Now, 16 combination 9, with no surprise, is going to come out to the same thing, 11,440 phone numbers as well. Pretty cool stuff. Let's look at one more question. It's actually kind of cool to answer if you're ever doing some sort of programming where you need to count some things. Stars and bars may be a handy way to do it. So how many integer solutions are there to the equation x1 plus x2 plus x3 equals 5? Right, well, all we know is that x1, x2, x3 have to be, and I should have said how many positive integer solutions here, because if we start to get into negative integer solutions, then it's going to get a bit more complicated to do that. So we'll just focus on how many positive integer solutions are there to create the sum of these 3 values being 5. Well, x1 could be 1, x2 could be 3, and x3 could be 1. Could have that. We could have 5 plus 0 plus 0, right? So again, this sort of is starting to satisfy the stars and bars concept where we have basically 3 digits and each one of them on one of 6 possible values, 5, 0, ranging from 0 all the way up to 5. So if we again think about stars and bars where, the stars, there have to be 5 of them. Why 5 of them? Well, because what we're going to think about is how an integer could be constructed from 5 stars, right? So we could say that x1 gets all 5 of the stars, and then x2 and x3 get 0 of the stars, meaning that they don't get any integer values. Now you can think about these as $1 bills if you want. Or they could be divvied up more, like we could have 1, 3, 1. Well, if we let a bar separate the variables from one another, and we wanted to represent 1, 3, 1, we could say, well, that would mean that x1 gets 1 star. And then we'll put down a bar indicating that x1, we're done with x1 and we're moving on to x2. Now x2 is going to get 3 stars. It's going to get 3 1-unit values, 1, 2, 3. And then that's all that x2 is going to get. And now x3 will have to be the remaining star, right? Because they have to sum to 5. How would we represent 5, 0, 0 if we took on that same approach? Well, that would mean that x1 gets 5 stars. We're done with x1, so we'll end that with a bar. Now, how many stars does x2 get? Well, there aren't any left to be had, so x2 will get 0 stars, and now we're on to x3, and x3 is also going to get 0 stars. Let's get one more possibility. Let's say x1 gets 2 stars. We're done with x1. x2 is going to get 2 stars. We're done with x2. x3 is going to get 1 star. And we always have 5 stars and notice 2 bars. So how are we going to answer this question? Well, we're going to say that we have 7 slots. We have 7 slots, and we can answer this one of 2 ways. We could say we're going to place down our 5 stars first, giving you an example of where those could go. Then, so we need to answer how many ways are there for me to pick 5 of those slots and place stars in them. And then there's, of course, only one way that you could place your 2 bars, right? That would be here and here. And by the way, what would this represent? Well, that would be x1 is equal to 2, x2 is equal to 0, x3 is equal to 3, and x1 plus x2 plus x3 add up to 5. Or you could represent this as 7 combination 2, and you could say, well, I'm going to place down my 2 bars first. How many ways are there for me to do that? And then the remaining 5 are going to get stars, and there's only one way to do that. Now, interestingly, if you compare this to our first problem, it's exactly the same problem, just a different context. Instead of having 3 grandchildren, we have 3 variables. And instead of having 5 $1 bills, well, we have that there are 5 stars where each star represents 1 unit. So as grandchildren, dollar bills problem. Pretty cool stuff. And it all boils down to, can this be done by stars and bars? And what we need to think about what each one of those things will represent.